So let's go on to machines here. Like I said before, the learning objectives are exactly the same as frames. We need to be able to identify two-force and multi-force elements. That's what we did today. Know what reaction forces occur at a pin connecting a two-force and a multi-force and a multi-force and a multi. If it's a two-force and a multi, anytime we have a two-force, we know the line of action. If it's a multi to a multi, it's an X and a Y component. And then identify and draw FBDs and use the equations of equilibrium to solve. So same exact things. Now, a machine and a frame then, so analysis procedure and our objectives are exactly the same. A machine, I think, really typically has like moving parts, where a frame doesn't necessarily have moving parts. So like this backhoe that I've shown you a picture of before, this is a really great example of a machine, but it's all just composed of multi-force and two-force objects. This right here, that has 1, 2, 3 locations of forces. It's a multi-force. The hydraulic cylinders, only 2 locations. So it's a two-force. And then our process is just to say, okay, identify all of our rigid objects. We can draw an FBD of each rigid object. What knowns do we have? What unknowns do we have? And then what am I going to pick? Another great example of a machine with multi-force and two-force members. Our homework problems are going to look like things like this, where we have like a set of pliers, some vice grips. But again, it might look like, oh my gosh, there's so much going on, but it's about identifying our rigid objects. Here's one rigid object. Is that a multi-force? Is that a two-force? There's an option for us to draw for our FBD. Same process here. Oh, and this is a homework problem. It's under the machines, but this is the thing that we talked about in the example we did today. This pin C exerts on member ABC. So it's right, the red colored text is different wording than our typical find the reactions at E. It's asking you for what it exerts on a member. So we can put this F1 over here, we can put it on the FBD of this one, or we can put it on the FBD of this one. We got to do it that, and then we got to do that one last step to look at all the net forces on C, at C on ABC, to figure out the correct answer. So it's exactly the same thing that we just did in our example today. And then on this one, write this down, problem 6.91, it's a 90-degree angle at F. You have to know that. They don't put it on mastering. We need to know that F right there is a 90-degree angle. And again, we're going to solve this by identifying our rigid objects and then looking from that list to figure out which FBD to use. So 691, 90-degree angle at F. Okay, let's actually do, let's write down one thing first, is under machines. And I think it's kind of just a cool definition here, is it is a system, so designed to change the magnitude and or the direction of a force. So I brought in, and you all can control, remember, like if you put it on speaker view or something like that, you can control how big my screen share is versus my video on there. So I brought in probably the most simple machine, or a really simple machine here. And it's just got one pin connection, and it's just like a pair of scissors basically, or a pair of shears right here. And so this is our simple pair of pliers here. And if I take I have a little wooden dowel here, and if I put the wooden dowel in there, right, I'm thinking what this machine is doing is it's changing the magnitude and or the direction of the force. And so I can go and I can put a force here on the handles, and I can snip through the board there. Well, let's take a look at how that machine is going to work. So our simple pliers here. And basically we have, I have like this had like a jaw here, and it kind of wrapped down around to this bottom handle here, and I'll just kind of make it look pretty straightforward. I'm not going to do anything fancy. And then a jaw up here, and did like that, right? And there was basically just A right here. We'll just say point A is a pin connection. So we have a pin connection right there at A. We put our, our wooden dowel went in here. Our dowel went right there, and I applied a force P there and a force P there. Let's add some dimensions to this. Like, what if we said, okay, well, let's just call this dimension from here to here. I can call that B, and then the dimension lowercase b, and then the dimension from here to here, I'll call that lowercase a. And so what I want to know is, what force are we going to get here? So what F do we get on that dowel right there when I squeeze through there? And we can say, we can set a value for P. But let's think about how we can apply our process that we've talked about to this problem. We said, okay, identify your rigid objects, right? What do I have? I basically have like the top jaws, like we can call it, how about the bottom? I've got the bottom handle and I've got the top handle, and those connect in. It's all one solid piece, right, of steel that connects in with the jaw part of it as well. So what kind of rigid object are those? Anyone in the chat, or turn on your mic. If I have forces on the handles, I have forces at A, and I have forces on the jaw, right? Yeah, it's a multi, right? Yeah, they're absolutely multi-force because there's 3 locations. So I have 2 multi-force objects here. My options for FBDs are, I could do an FBD of the whole thing. Now, the problem with doing an FBD of the whole thing with pliers is that a lot of times the 2 P's, when I sum moments, they cancel out, don't they? And so we can do an FBD of the top jaw or the bottom jaw here. It doesn't really matter. Why don't we just do an FBD of this one right there? So we'll do an FBD of the top handle. So we're going to have, at point A, we're going to have an AY and an AX. And I don't really care what direction I draw them in. I've already, I haven't drawn them anywhere else. We'll have our P over here. And then we're going to have on this one right here, we're going to have, where'd my dowel go? I lost my dowel already. How do I lose things so quickly? Okay, there we go. So on this, remember, we're squeezing onto this dowel right here, right? So what force does that dowel exerting on the thing that we're drawing? We're drawing the FBD of the jaw, right? We're looking at the jaw. Is this dowel exerting a force downward on the jaw? Yeah, right? It's not a force upward. We're exerting a force upward on the dowel, but there's going to be a downward force being exerted on the jaw. And so we can call it, maybe we'll just call it the normal right there on the dowel. I'm assuming everything is oriented vertical and horizontal for our little example here. We have some dimensions here. This is B, and this is a dimension of A over there. And we can come up with a relationship between the applied force P and the normal force I'm exerting on that dowel by summing moments at A. It's not only is it the pivot point, and so that makes it a good place to sum moments, but it's also the place that gets rid of the most unknowns. It gets rid of AX and AY. And so let's see, if we sum moments about point A, we're going to have a N times B minus a P times A is equal to 0. Well, let's solve for N in terms of P. N is going to be equal to P times the ratio of A over B. So I've got, here's my pliers, here's a ruler. So looks like we're about what, 6 inches or so, just kind of guessing there, like not 7 inches, right? Maybe it's about 7 inches or so. So that means, so if A is equal to 7 inches, and let's just make it easier, and let's say B is equal to 1 inch, and let's say that P is equal to 5 pounds. Let's say I was squeezing with 5 pounds. What am I going to get for N? What normal force did I generate? I'm going to generate 5 times 7 over 1. I'm going to generate 35 pounds. Now that's pretty cool. There's a machine, right? It changed the magnitude and or the direction of the force. We evaluate these exactly the same way as frames, so don't be afraid to get started on the machines homework that's due on Tuesday. We'll finish in lecture on Monday. We'll do this example here, so a little bit more complicated set of pliers. And then we will also look at a piece of earth moving equipment as well on Monday. And then that'll finish up and we'll be all caught up. We'll do those 2 examples with machines on Monday, and then we will be all caught up. So